Hello everyone. Welcome to Global Hack Week, day 6. And yes, this is the last session of the Python security series. If you have joined the previous two sessions, please drop in a hi and let me know. Today we'll be, um, yep. Also, here's the check in link. If you still haven't checked in, make sure to do so. I'll pin it up over here. Go and check in on the link and let us know that you're attending this event. And if you have attended the previous two sessions, the one on web app security and the other one on database security, let me know how you enjoyed those, or do you have some feedback for me and stuff like that. Today we'll be going through network security, and I believe most of these things might have been covered in the Global Hack Week, but it's always a good reminder to get to know stuff. And why did I choose network security with Python? Because there are a few things that Python can specifically do in protecting your network. Now, all of these things that I'll be showing up here today are very relevant to small scale projects and not like real industry level projects. So, if you have some hackathon project that's deployed somewhere, you might want to use these best practices and tools to help yourself safeguard from any vulnerabilities. All right, let me quickly share my screen. That's my presentation. All right. Just let me know when you can see my screen. Here, added it. Yep. Should be visible now. Just all right. Um, this is the second last session of day 6, and we have two more sessions after this. One will be adding authentication to your web application, something that I've extensively talked about in my last two sessions, and that will be with Harshil. And the next one will be reverse engineering with hardware. It is a series of sessions by John, and I think a lot of people are actually enjoying it. So posting the link to the schedule over here. You can check it out and check into other sessions that you might be interested in. And I believe we can begin now. All right. Hi, everyone. Again, introducing this network security with Python, and we'll be reading about or learning about defending against cyber attacks and intrusions. So, before we move forward, you might have seen me around here. My name is Akshita, and I'm an MLH coach here. I'm also the pod leader in the MLH fellowship team. Apart from that, I'm a full-time backend engineer, um, and that's about it. All right, let's move into our agenda for today. Starting with why network security. Now, we have learned about web application security. We've learned about securing our databases. Now, why do specifically need to secure our networks as well? So, as the slide says, network security is important to protect sensitive data or to prevent unauthorized access. If somebody gets access to your network, they literally have access to all of your database as well, right? So, a network is like a wall there. Your firewalls, like it's kind of different from that, but a network is like a wall that's protecting all of your assets that are behind that wall. Okay, all of your resources, your files, your server, everything that's behind that network, the network is kind of protecting it. And hence it's important to make sure that it's completely secure, it's not vulnerable to certain loopholes here and there. And yeah, all right. So, common types of attacks our networks face. What are the common types of attacks you think networks might have had, or something that you can suggest on the lines of what networks, what can attack networks? What are networks? What can cause a disruption to our networks just being there? Any suggestions in the chat? Wait for a couple of minutes. That's right. DDoS is definitely one of them. I think there's a DDoS challenge as well, this Global Hack Week, if I'm not wrong. Or did somebody take a session on DDoS? Hmm. I saw a lot of DDoS texts on Discord. All right, let's kind of delve into this. So one can be all obviously malware. Now, what is malware? We all know malware is all the viruses, the worms, the ransomware, the spyware, the trojans that we have, and malware can be spread via, the attacker can send it to you via email attachments or attachments on your uh, chatting websites, or other malicious websites. You download stuff from there and the malware comes hidden with it. Or say you install some apks, or you install some exe files or dpkg files, or some zip file where the malware is hidden, and you do not even know that it's been injected into your computer now, or it's been injected into your network. So malwares are something that's spread across the network, right? If one computer is affected, they make sure to spread across the network and try to affect all of the computers in the network. Okay. Now, when we're done with malware, let's come to the other kind. Um, yeah, that's not a problem. Anime websites. What do you mean anime websites send malware to your computers? I don't understand that. Also, creepy username. Yeah. All right. So the next kind of thing that we can think about that might affect our network would be phishing. Again, very simple. We did talk about this yesterday as well. We all know by now what phishing is. It's basically a kind of social engineering technique where the attackers will impersonate a website. Okay, they'll make an imposter website very similar to the original one, and probably just make a URL very very similar to the original one. So people who cannot remember URLs and simply just click on any link that they're given, they might fall into these type of attacks, right? And you'll enter your username and password there. The UI and the UX will be very very similar. You'll not be able to find out how different this is from the original website. You'll put in your username and passwords, and lo and behold, you'll just fall into the trap, right? Does anyone know of any phishing websites? Oh, so you're saying anime websites are full of malwares and ads. Right. Not all ads are malwares and not all malwares are ads. So that's something that has an intersection, but it's not mutually inclusive. And yes, anime websites, there's a lot of news websites that do have these things. And I think a lot of, if you might have encountered this in your, I think, online classes, when we try to look for answers during an exams or tests, and we find these websites that claim to give us answers, and they tend to redirect you from one website to another, like click on this link and we'll get the answer, or download this link and we'll send you the PDF. So all of these things, we should be very aware that all of these things are not actually going to help us. They're just sending malwares into our PCs, And most of these go undetected by the antiviruses that we currently have, because for every one single antivirus that is made, people find out hundreds of new ways to bypass that, right? Now, once we are done with phishing, we have our DDoS, which is, does anyone know the full form of DDoS though? DDoS attacks are very famous. It's super easy to program one, right? Does anyone know the full form of it? I'll give you a second to type it out if you know. Right, denial of service attack. Well, it's not exactly denial of service attack, it's distributed denial of service attack. Now, as the name suggests, what it means is we are trying to attack a service with a flood of requests. Okay, so if there's a website, we are trying to send millions of requests at a single point of time so that its servers crash, its gateway crashes, or any kind of thing that we can do to harm it so that the service goes down is called a DDoS attack, right? And not only, yeah, everyone's writing denial of service. It's distributed denial of service. So you distribute your attacks to go in at the same time to attack the service. That's why it's called DDoS. All right. So now, what DDoS attacks can do are literally, okay. So you have an e-commerce website, a very famous one. Let's not name any, but you have a very famous e-commerce website, and I make like say 20 scrapers that will be distributed in 100 Kubernetes pods, and I tell those scrapers to hit the website at the same time, right? This will say I have 20 scrapers distributed in 100 pods multiplied uh, certain way. Say I have 20,000 scrapers now, and I tell them to hit the website every second. So this website will be getting 20,000 requests per second extra apart from the already incoming requests. If this website does not have a very good load balancer or anti DDoS prevention, then what will happen is this gateway will crash, the servers will crash, they'll not be able to take so many concurrent requests at a time, and the website will be down. Now, why would somebody want to do this? People might want to do this to their competitors so that they suffer financial losses, or their business operations might be impacted. People might want to do this just for fun, right? So if somebody just gotten into, say, security and stuff, and they found out, okay, I can do this, they might want to try it on some website, and just out of pure fun, just to trouble somebody, they might want to do an DDoS attack on their website. Third, third, no, fourth. Fourth, we can have something like network intrusions, right? And when we talk about network intrusions, I think these are the scariest type of attacks that somebody can do to a network. That's when you have a certain, say, a cloud IP, right? And somebody wants to gain access to it. Now, we all know that in today's world, like if you have worked with GCP or AWS or DigitalOcean, we know that it's not very easy to break into these networks because they're behind closed walls. Okay, they're behind, they have restricted access, and not everybody can just go and exploit their vulnerabilities. However, just in case somebody finds a loophole. People are brilliant, right? These people who do these attacks, they're brilliant. They're very, very intelligent, and they know their way out. So what they can do is they can log in into your network pretending that it's you, or that they're an authorized user if it's not you, and they can steal your data, they can modify your data, they can gain control over your entire server and probably just shut down the server or delete everything from there. You will be dumbstruck when you find out what had happened, or probably you do not even get the chance to know what had happened to you. Maybe they can store, maybe they can steal your credentials. We store our secrets, we store our all our passwords and everything in the environment files or environment variables, or these pipeline variables on these hosting sites. Now what happens when somebody intrudes into your network, when somebody makes a very sly entry into your network without you getting to know about it? They can steal these credentials and use them as they want, and you will probably not even get to know about this. So This is kind of scary. Now, yeah, I hope the font is big enough. Now, since I had problems yesterday sharing my VS Code screen, it wasn't sharing on StreamYard, there was some issue. I decided to put the code snippet over here in Canva. There's one add on here which is very nice. This plugin allows you to put code in a formatted way, so that's cool. Now, what is this? This code is. Can somebody guess what this code does? If you run this code on your friend's computer, what will it do? Very simple Python code. Can you guess what it does? Obviously, there are comments. Figure out. Oh, there's somebody from Facebook joining us. Hi, Babin. I'm sorry if I pronounced that wrong. Anybody could make out? Okay, all right. I'll break it to you. This is a simple virus, the simplest virus we can write. Probably a very simpler one than this would be just run a while loop, okay, and go on deleting every directory you come across, and that will be the simplest virus one can write. Just asking, is a background noise from my end? Because there's some, I think, drilling work going on in the room beside me. I can hear this super clearly. Can you all hear the background noise that I have? Sure. Okay. Okay, then I'll go forward. Right. So this code, what it does is it simply appends a simple message to your text files within that particular directory that you want. And while this is not very malicious, but it's kind of freaky if your friend has some txt files in the directory and they've suppose made notes out of it, and you want to just, I don't know, you just want to play around with them. uh, run this program into the computer, and this will act as a virus. A virus is something that wants to do something malicious, which ideally would not be very ethical to do with somebody. And yeah, your friend will suddenly have all of their text files appended with your signature and your tagline, with love, Akshita, right? And when they try to send their text files to somebody, they'll just get this added signature in the end. Or this, probably your file has been infected. This is even creepier, to add to somebody's text files. It's a very simple virus, something that you can try. Don't try it purposely to harm somebody, maybe as a joke. Now, here is our favorite DDoS attack. Super easy code. Again, this might take a few tweaks here and there if you want to uh, DDoS something like your own server, okay, which is not exactly well managed, or maybe your hostinger sites, right? So where you've not put load balancers, places where you are sure you are authorized to do such things. Do not DDoS attack on other people's websites. You can try DDoSing your own, and you can see how this turns out. So what this code does is it sends multiple concurrent HTTP requests. So you can see we are creating around, say, 10 threads, and with those 10 threads, we are continuously sending requests to this particular target URL. Now, please change this target URL to your own website or places where you're authorized, and you can try out this thing. It's super fun to do. Um, Now, yeah, this can also be kind of taken up as a practice if you're trying to learn about load balancers, okay, and you want to see how much can you scale your infrastructure to handle the load coming from various requests, you can try making a DDoS attack on your websites where you have put a load balancer, and then you can see what are the configurations of the load balancer, how can I change it, how can I modify it, and you'll be good to go then. Next, now this is a big term: network scanning and enumeration. What this means is we are investigating a network to gather information about its hosts, services, and vulnerabilities. Now this sounds like ethical hacking. It's not actually ethical hacking. We're just trying to investigate what the network actually contains right now. We are trying to check the network, whether it has some active host, what are the open ports in the network, what services are running right now, are these services expected to run, are these ports expected to open, did I open these ports or did somebody else open these ports, right? So all of these things in a network are kind of important to know. And by performing this network scanning, what you can do is you can find out what your network architecture looks like, what potential ports or what potential host can get affected. So you make sure that those ports are specifically secured, and which places do you need to prioritize your say security practices, right? A little more into this now. There are four ways in which you can do this, right? One is port scanning, like we discussed. Now, while port scanning, you can you can figure out what ports are open, what service is running on which port, right? Is that service supposed to run on that port or not? Or do I have a duplicate instance? Or do I have some external service connected to that port which was not expected? Okay, suppose your Flask app is running at port 5000, but an external service of some other server is connected, a socket is connected at 8000. You did not connect the socket. Where did it come from? This could give you an insight of a possible intruder in your network. So port scanning comes in really handy over here. All right. Now Python has this library called Nmap, which is which provides you functionality similar to. Just let me quickly pull up the link for Nmap. All right. Now this one provides you functionality very similar to the Nmap that we know from our Linux kernels. Yep. Pinned it over here. You can check out this. There are other variations of the same project. One is Python 3 Nmap, Nmap Python. So you can check out which library feels like the most comfortable to you. And you can try out these things on a smaller scale. Definitely, you can scan your own ports. Okay, next is service fingerprinting. What does service fingerprinting mean? As is clear from the name itself, service fingerprinting means we could basically know that a service exists, right? And then yep, okay, sorry, yep, we know that a service exists, and we can check uh, which service calls which resources at what intervals, right? So if my service is running a Flask app, all right, and it's trying to access Redis, say twice every 1 minute, that's its expected hit rate. Okay, now suddenly if my service wants to access Redis, say 10 times every 1 minute, I'll need to kind of have my alerts on. I'll need to know why is it wanting to hit it 10 times when my expected or my average hit rate is twice per minute. So this is very crucial in knowing when your service gets infected with something. If somebody infected a code, right, and just wants a service to get more and more data from your Redis database, that person will want to hit it more and more so that they can scrape out maximum amount of data. And that should be an alert that you can set. And again, service fingerprinting is something you can do with your nmap libraries, which are provided in almost all languages, not only Python. The Python one I've linked here. Then next we have vulnerability scanning. Now, apart from these port scanning and service fingerprinting, vulnerability scanning is also where so what scanning tools we are using, they can also scan our databases, right? And our databases have certain known vulnerabilities which we talked about yesterday, and we can match them against detected services and configurations for a host. So our host is configured to host a database on a particular IP and particular port. If there's a replica of that database connected somewhere else, that's a red flag. Okay, we did not set this database up. Why is that instance over here? Correct. So now if a vulnerability is found, our scanner should be able to tell us immediately that, okay, this database instance was not supposed to be here on this IP, and I think you have a duplicate and your data might be going into the wrong database. This is not your database. That is when vulnerability scanning comes in help. Now we have the last one, which is misconfiguration detection. Again, if your service was supposed to be sending responses, okay, to a certain set of IPs. Suppose you are building an internal service which is supposed to only work with um, say five other IPs or five other computers over the network, that you have decided that I do not want to expose this particular service to the entire world. I want only five IPs to have access to it. But suddenly, there's a sixth IP that is also connected to it. How did this happen? Somebody might have changed the configuration of your service to also connect to a sixth IP. Now, this is what we mean by misconfiguration detection. Now, again, all of these scanners, these scanning libraries in Python, they help you detect all these in real time and send you alerts on them. All right. Next, we have intrusion detection and prevention. Big terms, difficult pronunciations, I understand, but equally important. So now, this is also famously known as IDPS. If you are into security, if you have attended these sessions regularly, you might have come across IDPS much more than just once. So there are two types of detection that we can do here. That is, one is signature based detection and one is anomaly detection. Signature based detection, again, as the name suggests, you already know that there's a certain signature that a particular attack or a particular malware or a particular type of intrusion can have, right? So you know SQL injections, how they happen. You know the signature of that. You can quickly detect how to avoid it. Again, now you know the DDoS attacks. You know the signature is too many concurrent requests at one time. You know the signature of it. You can identify certain things, and this is how you can, again, you can write code to prevent such things. You can you can block IPs from your gateway. You can block certain IPs which are consistently hitting your service in a very very less amount of time, right? So uh, you can put all these predefined patterns into your database. Okay, that this particular attack has this kind of pattern, this particular attack has this kind of pattern. And when an incoming say event or incoming data matches these signatures, right, then you immediately get to know that, okay, I'm being attacked right now. This is something that I knew, I can detect right now. And it is very effective it is very effective against known attacks, type of attacks that we already know about. Because see, again, DDoS, SQL injections, or even say, what did we learn about here? Misconfiguration detections. Somebody switched up with our configuration. We know we can detect these kind of attacks, and we can write code to prevent these. So these come under signature based. What is anomaly based? Now, anomaly based, as the word suggests, is when something goes something off with our service, something that we did not expect. So, like I said, suppose my hit rate was twice a second, twice a minute. Suddenly, my hit rate has gone to say 30 times a minute. Now, that is an anomaly. That is not expected out of my hosted service. That is something that is very abnormal, uh, and my network is not used to such kind of things. So these are anomaly detections. These can be set up by defining a normal behavior, that okay, this is my average request rate, But if the request rate goes, say, twice or thrice this threshold, then you give me a alert. And all of these are very, very popular in the Elastic. Yeah, Elastic APM. Let me quickly pull up the link for that. I think somebody took a session on observability. Um, we aren't really going to do any practicals today because it's not entirely ethical or suggested to show people how to create attacks. And yeah, also I have some issues with sharing my VS Code screen on StreamYard here. I'm really not sure why is that happening, but it happened yesterday. It's happening today. So I do have these code snippets that I shared here on my GitHub repo. I'll share the link to that GitHub repo here as well. You can refer to these later. All right. So I dropped in the link to Elastic Observability dashboard. And if you get to read more about this or even get to use this anytime, it's absolutely great when trying to detect anomaly detections. Can I show my let me see if I can show what I have on my dashboard. It's taking a minute to load. Okay, while this loads up, let's move forward. Okay, now since we have talked about the like numerous amounts of ways where how we can get attacked, how do we do secure network communication? How do we just make sure somebody is not listening to our messages or our data being sent here and there when we are communicating over a network? What do you think this is? Does somebody recognize what are we trying to do here? Sorry for that slight change. On the first line, we can see import SSL. Yes, we're talking about SSLs. What is an SSL? Does anybody know the full form of SSL? Where have you heard about it? We all might have heard about it. Yesterday we talked about an SSL. Yes, Parth, that's correct. Does anybody know the full form or the use of why we use SSL? In practical life, where have you seen SSL being implemented? How do you know that a website has SSL certificates? Okay, yes, correct. Secure sockets layer. Now tell me, how do you know? Correct. Secure socket layer. How do you know? Very nice. HTTPS. So if a website has HTTPS, the S stands for secure. And that S is added to it only when it has an SSL certificate. When it has a secure socket layer certificate, that okay, this website is secured, the data across going across this is encrypted, and nobody can possibly, in a very simple way, intercept the data that we are sending across this website. Then we give that website HTTPS. All right. Now, this is a simple socket connection in Python, right? How do we ensure our socket is secure? We make an SSL socket. We wrap our socket into a um, we wrap our socket across an SSL, okay? And we okay. Now, how do you get? Does anybody have any to get certificates without having to pay money? Because we know for our websites that are hosted, we pay money for HTTPS. But for local testing, like as shown in this code snippet, how do we get these certificates? Has anyone tried that out before? Nobody? All right. So there's this, and there's something called OpenSSL, which kind of helps us. It's an open source library. This website, if you follow along the tutorial on this website very clearly and properly, it'll help you generate an SSL certificate for free, right? And yeah, you can use it to secure your socket on your local system. All right, let's move forward. And yeah, wrap our socket in SSL, and hence we have a secure socket connection. Now, this is how a SSL process works. We have a client. It requests the servers that, I am only going to connect with you if you have SSL session right now. Like our browsers, they suggest us that this particular website does not have SSL certificate, it's insecure, it might potentially be dangerous, attackers might be trying to steal your information, so do not connect to it. But we still click on proceed anyway. So our client asks the server, do you have an SSL session right now? The server responds with the SSL certificate, the one that we passed over here, right? And the server responds with a public key for that SSL certificate. The client does what it verifies this, and it does what it wants to do. It sends its data back, which is encrypted in a session key, and it's sent back to the server. Now the server uses that data, it decrypts that session key with a private key that is generated when we generate our SSL certificate. Okay, it works very similar to your if you've used GitHub or Bitbucket with SSH private keys, it's very similar to that. And then the server sends back encrypted data with a very symmetric session key. So this is how this looks very simple and is actually very simple once you get to know the hang of what the certificate contains. Now, to understand it better, I'll give you a very small example. So suppose SSL is like a special box. It's a closed box with a lock in it, the key of which only your friend has and you have. Right? So you two have the key to open that box. All right. Now, when you send your box to your friend, you post it. You send it via post. It travels all the way through different states and countries, and your friend gets it. Okay. But if somebody tries to open that box, they cannot because it's locked. It's a wooden box. It's locked, and the key is only with you and your friend, right? Suppose it's made of titanium or diamond, and nobody else can break this box. Let's assume that. All right. So our network packets are like this. If it's encrypted with a secure private key, nobody else can break into it, and this key is only with the recipient and the sender. So your friend and you have this box, and even if somebody holds this box, even if somebody comes across this network, they cannot look at what is inside, what you've sent to your friend. And once your friend gets it, they can use the key to unlock it, right? They can read whatever you have sent them in a message, and they can write you back a letter and send it in that same box. So that box acts as your SSL certificate that certifies that this thing is not going to open if somebody does not have this particular key. And this is how basically SSL handshake works. Moving forward, another thing that we come across in network security, that is SSH. Now, Paramiko is again a very useful library in Python for establishing SSH connections. Let me quickly drop the link to that as well. This comes very handy when you want to build your All right. I think there's a little problem with my data. Cool. Also, just give me a second. I think I might have a custom SSH server built. I used Paramiko in one of my projects. Here it is. So I created a mock SSH using sockets in Python, and here are the screenshots. Let me see. Oh, right. This is the ASCII art. It's loading very slowly. Yes. So well, here it is. Nobody should store the private key like this, but I had to submit it to like my college, and hence it is here. Oh, this is a private project. Thank God it's a private project because I put my private key over here. Very, very kiddish of me. Anyways, so let me find where did I? Oh, here it is. Connect ssh.py. I'm using Paramiko here to connect to my SSH client, right? And create open up. Yep. All the command lines, very badly written code, but it does its job. It kind of works. Executes basic. Um, See, it authenticates you using your private key and executes basic commands like rm or who am I or pwd, ls, sudo, all of these things. Right. So let's go back to our presentation. Sweet. All right. So what this is doing is now what SSH is, it's secure shell basically. It's a secure protocol that you use to securely access a remote server, something that you have access to, and it lets you log into that without revealing your credentials to anyone on that same network, right? It not only provides encryption to your data transfers that you're doing, but it also provides you with authentication or integrity that okay, this is somebody who's authorized and they're integrated. Sorry, I can identify that they are um, that they belong here and they can access this data. So SSH allows you to do all these things. Then Paramiko is the library which is very very famous to establish SSH connections, and you can see how simple the code is. There's some boilerplate code that you have to add over here, right? And then you simply connect and you take input, output, and errors that are there, and you can execute these commands. So if you'll open this SSH client, this will open a client in the background, and exit command will allow you to execute these commands on this client, right? All right. And then when you have your input, output, or errors here, you can simply print those and read out, and you can close SSH session. Again, very simple and nice code to try out a mock SSH example in Python. If you have your, I think you can just type in SSH in your Windows or Linux terminals to kind of get the feel of it. Now, this is how SSH work. A little different from what SSL was. It can be a bit confusing, but it's a little different. So what happens is this thing is secured. This thing is secured. Nobody's requesting anyone. Both are there. There's no third party here that can connect with me. There's no third party here that I can connect with. All right. So yeah, the client and server both are secured and both know that we have our own keys. There is a public key that everybody knows that these two are connected. There's a private key that only both of these know that okay, if some if the client verifies this private key, I know that they are my client. Or if the server verifies my private key, I know I have access to the server, right? So SSH kind of becomes like a, it's like a closed tunnel. So now suppose you had that friend you sent your magical box to. Now if you want to visit their house and you dig this tunnel, I don't know from where, like Doraemon's anywhere door, okay? And you dig this tunnel and you keep sending things from that tunnel back and forth, right? So now you send that box through that tunnel, and that person, your friend, everybody around knows there's a tunnel. So that's your public key. But can everybody access the tunnel? No, they cannot. Why? Because it's between your house and your friend's house. Now, the key to your friend's house is only with them. The key to your house is only with you. What you can do in this tunnel is something that you both decide on. You can send data, receive data. You can establish a connection. You can just simply say hi to them through the tunnel, send this gift, receive gifts from them, or you can just go visit their, you can log in into SH server and perform operations there. You can visit their house, and you can, open their fridge and have snacks from there, right? Or you can play together with them. So this is something that SSH allows you to do securely, all right? And a very useful or everyday implementation of this could be when you are using AWS instances like EC2 instance, okay? And obviously there's an inbuilt CLI on AWS dashboard to connect to your instance. But on the other hand, on your computer sitting here, you can type SSH, and you can type the instance key ID of your EC2 client, and you can log into that EC2 server, and you can perform actions there. You can start up a Docker server there, you can send emails from that server, you can just entirely change the configurations of that server. You can install various flavors of Linux on that server and whatnot, right? So how does that happen? SSH allows you to securely log in there because you have the private key, you have the public key, and it knows that you are the person who has access to the server. So that was something about SSH. And with that, we come to the end of today's session. I wrapped up pretty early because that was all that Python has to offer with respect to network security. But yes, we are open to questions now. Why session key is not used in SSH? All right, so session key is not used in SSH because I'll go back to the, because we have our private keys, right? Also because both of these are secured and encrypted in their own ways. Here we are sending data which is encrypted in session keys. All right, I hope the difference is clear. Here our entire pathway, our entire tunnel is encrypted. This pathway is only encrypted. Nobody's allowed to enter this tunnel, if that's clear now. However, people are allowed to see what's going on here. They cannot access the data. People can access the network packets that you send to the server, but they cannot, figure out what's written in it because it's encrypted. They cannot decrypt it. They cannot access your data. Here, they just know that okay, there's a tunnel somewhere, but they cannot see the tunnel. That is why session keys are not used here. Okay. Keep your questions coming in. Any other questions about Global Hack Week in general, about where you can find this? Let me share the link of my repository. I shared it yesterday on Discord as well. You can try out these code samples. Also, the next Global Hack Week is again season launch. Hope to see you all there. We're having some exciting things in the new season for all of you. Security week, here it is. Copy link and paste. drop the link to the repo here. I will push my networks code after the stream ends, and you can try out the code of that DDoS attack or the ones that I showed. You can try out this code is there, this code is there, this is there, this is there. Also, yeah, there's port scanning and fingerprinting code also inside there. So you can try looking at it as well. All right then. I'll wait for a couple of more minutes for more questions to come in. There are any regarding any challenges you face or questions about further sessions that are about to happen, let me know. I'll be happy to answer. All right, everybody, then thank you so much for tuning in. Let's hope to see you again for a future Global Hack Week session. And yeah, goodbye until then. Have a great day, have a great night, or whatever it is in your time zone right now. And enjoy the weekend. I hope um, we see each other again anytime again. Also, I'm in the Discord server. Feel free to tag me or DM me or whatever.